Times where I've failed, right, and it didn't matter, and there have been times where I failed where it's like in front of my boss or something like that, right? And I would have wished maybe that I would have done that in a different circumstance, right? So think of like this is that sort of not okay? So we were talking about information management, and we're going to get into today, finally, connecting some pieces together, right? I mean, we were talking about how data gets represented and how it has internal representations for editing and external representations for distribution, right, for use in other applications and things like that. We were talking about how data gathers information, right, how we can synthesize this stuff. But ultimately what we're interested in making is what's called a CRUD application, C-R-U-D, meaning an application where you can create data, and by create data would really mean persistent data, data that will be there later, right? I log into my computer and I change something, and then I log into my phone and I can get it. It's there later. I've created something, okay? So I create a Google Sheet. I can access it from multiple devices. I can retrieve it. Hey, I want to view it. Okay, good. I can update it. I can change something. I can delete it, right? All of those things. And those are the fundamental 4 types of interactions that we have with a database. Create something in the database, retrieve something from the database, update from the database, delete something from the database. Now, we're going to look at 2 different types of databases. Today, we're not. All right? Today we're just using one database, and that's MongoDB. In fact, right from the start, in a minute, I'll tell you to install a couple of things, okay? So if you have your laptop, I would encourage you to take it out and we're going to install a couple of things, okay? But we'll look at how to do this with MongoDB initially. Understand that you can do this, of course, with a variety of different databases, and actually there are many categories of databases. There's really, we typically think of them as 2 broad categories. What we call a relational database, which we'll see later with MySQL, and a NoSQL or JSON database, which is what Mongo is. Okay? It's important that you understand both of them. Both of them are very commonly used, but there's a million of them. There's Oracle, which has made Larry Ellison the wealthiest man on the planet. He owns an island, like the 7th largest island in Hawaii, just because he's a horrible person. Ask enough people. But you can ask about the acronym Oracle. But databases, there are actually many, many different types. There's Postgres, there's all kinds of different ones. Right? But we're going to focus on the 2 broad categories, and that's good enough. All right? Okay. So I mentioned, in homework 1 and 2, of course, we're using local storage, and maybe in the browser, if you're looking in there, maybe you'll see, oh yeah, there's this other thing, web storage. It's actually, I'm not really going to get into the differentiation between the 2 of them, but there's actually another thing that we are going to play around with, which is cookies, right? And cookies have been around for a long time, much longer actually than local storage, right? Cookies are typically used to store a little bit of information just to make it easier for the user to pick up where they left off, right? In a small way, like their account name or something like that, or last access, or things like that. But we don't typically store as much information in a cookie as we could in local storage. I mean, local storage could literally have all of the stuff that we were just editing. Right? I mean, we could store local storage, hey, we were just editing stuff, all these objects are in there so that if we lose a connection, it's still there. Right? So I want you to understand the differentiation in terms of usage between the 2. We would typically use cookies for a little bit of user information. We certainly wouldn't store a password or anything like that, but a little bit of user information. And then to make presumably some login task a little bit quicker. And then, and maybe even for tracking information for websites. And then the other thing is local storage, where, again, the idea might be, hey, let's store stuff that we're editing currently, so if we lose our connection, we can pick up where we left off, or something. A little bit of that. All right. So that's on the client, but of course, hey, if I'm on Google Sheets, I don't just want things stored to the client. I want to put in the back-end database, and the back-end database, I can, of course, get it later. I have to save it now, get it later. So, first of all, cookies. I mean, there are some rules with cookies. These are just simple text files. You can go in your browser. If you open your browser, everybody, go in your browser, and, you know, same sort of place where you can see, I mean, where is it in, let's see, over here. If I'm over here, let's see. And I go here, and more tools, and developer tools. Let's see, we have over here, we have our local storage, and there you can see we have our cookies. You can open up cookies, and you can see all of the different sites. And for me, I have 3 cookies, they're all from Google. Okay? So I have 3 Google cookies currently on my Chrome. All right? And what data are they storing? I'm not really sure. Presumably something about my username and stuff like that to make it easier for me to log in or something. Okay? But the hope is that we say here session-to-session storage, right? Session-to-session usage. Like this is a session. I just turned the computer on. I'm using it. I'm on the account and everything like that. I close my computer. I come back later. It's again to help with session-to-session stuff. Okay. Understand that a session is, hey, I've kind of activated a session by interacting with the website, and so I'm using it right now. And so the server might be doing some things right now, but if it knows that I'm not using it anymore, it won't do those things anymore, like forward me notifications. It won't forward me notifications if I'm not currently using it. It's not, the session is over, right? And as soon as I pick up another session, then it might decide to work. Right? So the server will keep track of things like sessions. I mean, we pretended to do that a little bit. Remember, we did a little bit of, for these key name pairs, we pretended, we didn't really do it. Okay? But a server certainly could keep track of it. Anyway, they're just simple text files. Like there's nothing fancy about them at all, right? And understand that they have size constraints. So there are some size constraints as far as how large a cookie can be, right? These little text files. And they're very easy to write and read from in JavaScript. Like JavaScript is built for cookies, okay? So look at that up top, document.cookie, right? We know what document is. That's a global variable. That's available in every browser. Every browser, presumably, can store cookies. So I can do that up there, okay, with cookie. I can essentially get a cookie. I can replace the contents of the cookie such that it has name value pairs. I can give it whatever I want, right? You can see, like this top one, document.cookie, I'm giving it a property called username, all right? Now, when I say document.cookie, you have to understand, we're telling the browser for this website. Like the browser will figure out, oh, for this website. So document.cookie, username is assigned Joe. It's saying, okay, for that cookie, we're going to have a property called username, right? But I can also change it. Here you can see I'm using this. Anybody know what we would call that? Like a regular expression, yeah, regex, right? If you ever take CSC 303, you'll learn about that, okay? It's just a mechanism for finding various combinations of string patterns for doing whatever it is that you like. And then down here, I'm actually deleting the cookie by changing the expiration date to the past, right? So, you know, you get used to this. This isn't particularly complicated. Should we extend the quiz, everybody? Look at the mean people saying no. I can't believe these mean people. We had a rainy day quiz. We extended this. I want to know the meaning of life. We'll extend it to, what time is it? 12:50? 1 o'clock. Okay. Okay, click on this and see what you submitted already. So, go to Brightspace, you only have 10 more minutes to submit today's quiz. So, we could of course also store multiple main value pairs, right? We can store as many main value pairs as we want, right? Just like you can hold the store. Right? So, that's what a cookie is. Okay, and we're using cookies a little bit in this next assignment. We're certainly going to use them in homework 4. Right? We've already talked about local storage, right? And again, you know, this is a mechanism for the browser to store typically larger things that are in the process of being edited. Like you're in the middle of doing something and you lose a connection or something like that, right? And there's something called progressive web apps in particular. The philosophy is, hey, even if you lost your connection, we still want to keep the user engaged. I want you to think about Facebook or something like that. Like you're on a subway and you have a signal and then you don't have a signal. Let's not just give you a blank screen. Let's actually let you still post things, and we'll tell you it will be posted as soon as the connection is available. Like apps will work that way. And then as soon as you're back in a place where you have a signal, it will actually post it. Sometimes it will post it multiple times. So we've already seen this, right? I mean, we could either use local storage from window, or we could use session storage from window, right? And difference, of course, is the expiration date. No big deal. I mean, we've already used local storage, but we can do something similar with session storage, right? So we already know how to do this. This is no big deal, right? We already know how to get data, how to set data. Nice and easy, name value pairs, right? So now we're interested in, of course, using a database management system. Again, for this database management system, I want you to understand, and you might see there, I don't know if you remember, in 214, relational databases management systems for large systems. One of the most common data structures underlying it is actually something called a B tree, which if you ever taken 214, you probably talked about it and never implemented it. I always liked B trees, so whenever I taught 214, I would have students implement it. They're basically trees with multiple nodes, and there's like a whole algorithm that's used where it's in sorted order according to key, and they interleave the child nodes according to, you know, the keys in the parent node and things like that. But anyway, we want to learn, hey, how can we put things into a database that's going to be on a server, and that database is going to require accounts and things like that. So we'll just initially do it without accounts, which means we just have to have our server connect to the database, but later we'll get into how we actually can have the server act as a beacon. Okay? So these are the two broad database management systems that we're going to use. Again, 2 categories. And we'll start really with the NoSQL one, with JSON. But actually, this is the older one. This is the one that's been around for much longer. And if you're wondering why, like what's wrong with relational database systems? Some people love them. I worked at a company, and you know, their whole system, their ERP, Enterprise Resource Planning, which would basically manage everything from the materials that you ordered to the parts that got assembled to the bigger products that you sold. All of those different things were all managed by this ERP, and it had a whole database associated with it. And one of the highest paid people around was the person who was sitting there writing queries, right? Essentially writing SQL code And that SQL code was essentially retrieving things from the database and such. Right? So we will certainly learn how to do that with some SQL. We're only going to do simple things with SQL. We're not going to do super complicated things with it. We're going to pretty much do CRUD in homework 4, okay? And then in the final project, you get to choose which one you want to use. Do you want to use the NoSQL relation, okay? But we're going to make use of, in homework 3, a new NoSQL database, which is very much like just reading and writing to a JSON document or JSON file. In fact, it uses the term document, right? So we have a collection, which would be a bunch of JSON files, and each JSON file would be a separate object, so to speak, okay? So if you want to think about what a JavaScript object is, right? A playlist, okay? A playlist has a bunch of variables, and we can save it to a JSON file, well, just the way we did in local storage. Very simple, right? There are advantages and disadvantages of each. I think the advantage of using NoSQL databases is that they're easier for the programmer. You don't have to hire, necessarily, an expensive SQL programmer, right? The disadvantage is that, well, relational databases are well established and can be optimized by people who know what they're doing to write really complex queries that perform well. I think that that's probably what people would argue, right? But anyway, depending on what you like, you can use whichever you want for the final project, okay? So we're going to get into today a bit about how to set it up and install it and use, because what we're going to have to do is we're going to have to install a database program or use a cloud database, okay? And we're going to have to start it, and basically what that means is a server. Like a database has a server, meaning it has code sitting there waiting, like, does anybody need anything? Does anybody need anything, right? And it listens on a particular port number. And our backend server will connect to that database server. And it will say, yes, I want to make a new playlist. Make one. Okay, yes, I'll put it in there. And then we'll say, hey, database, give me this playlist. Okay, here you go. Or change this playlist. Here you go. Right? Or delete this playlist. All of those different things. So I want you to understand, we're going to have the database program itself. In fact, the name of the one that we're going to install for homework 3 and we're going to do today is MongoDB Community Server. That's what we're going to install and use. And you could alternatively, I have it running right now on this computer, you could alternatively use Mongo Atlas, which uses it as a cloud. Okay, so you can use either one actually. It's just important that if you do it that way, that during testing, you know, the TAs, they will do it. So it might even be better really just to stick with the local one just to avoid those types of complications. All right? So, but it should work, you know, even if you use Mongo Atlas. Right? All right, anyway, so we're going to install the server, and then we're going to start it. And MongoDB, for example, has a nice user interface program, because the DB itself is just the data. All right? It's just the data, creating, retrieving, updating, and deleting things from the data in its particular format. But then it has a user interface program called Compass, and that's what this thing is, and I'll show you Compass open in just a second. And Compass lets you have a view of everything that's in the database and lets you do whatever you want. Okay? So that's where we're going to go. Now, there's another thing that we have to worry about, and that is called an ODM, an Object Database Mapping API. Now there's also something called an ORM, which is a subtype of that. That's an Object Relational Mapping. What is this? Basically what it is an API where you in JavaScript can write code that can talk to the API, and the API knows how to talk to the database. That's all really we have to worry about, okay? And really the whole idea here is, you know, if I am using Mongo, I'm going to use their ODM, which is called Mongoose, which has a bunch of pre-made ways of creating, retrieving, updating, and deleting stuff. All right? You don't have to use them. You could theoretically actually write your own, but they're a good starting point, and everything we want to do in this semester, we're going to do. So Mongoose is our ODM for Mongoose. And again, Mongoose has methods. It has a method, for example, find one. Like find one is like, I want you to find this particular object. Hey, I have a database full of playlists. Find one. Well, what is it going to find? It's going to find you provide parameters. Like find one where the ID is so-and-so. It finds one very particular one where the ID is so-and-so. All right, that's the name of the method, find one. There's another method called find all. That gives you every last playlist, right? Or you can actually give a parameter that it passed some criteria. Find all, and it meets some criteria. Find all of the playlists, right? And you might have a criteria in there that has a song that was released in 1990 or something like that, some random year. Or find all the playlists that have a particular artist or whatever. Okay? So I want you to understand that these APIs, Mongoose and Sequelize, they know how to talk to the database. Okay? We just have to learn how to talk to them. All right? So let's see how we can do that, and we're going to use an example that I very much like, which is online, and I have it cited in the lecture slides, and it's also in the course schedule. So if you go to the course schedule here, let's see, where is the course schedule? All right, everybody submit their quiz. Did I change it? I did, right? 1 o'clock is 1:01. Yes, no? All right. How about today's lecture? See right here, movie example, repo, we're going to use that. So if you click on this, you will see that it will give you that shouldn't happen. I put the wrong link in there. Okay, you're about to see magic happen. Let's go over here. This is my program that I made for updating my web page. Let's see, movie example. What link did I put in? Oh, I put the text. I didn't put the actual. Let's see this. Right here. This. Take this. We're gonna put it in here. This was an assignment in this course one semester. See, sometimes I like making assignments, but I'm like, well, I need to make this. I might as well make everybody else up. And is this 316? It is. We'll just do this. So someday you'll see that I'll be making a fortune on clothes. I doubt it. Where were we? Here we go. All right, let's see. Is it there now? Now it is there. Okay, so this is the repo. Ooh, you like my dark mode? This is the repo, and you'll notice inside of here that in this repo, right, which was not created by me, it was created by somebody else who, I have the tutorial that I'm citing here in the homework, in the lecture slides. It's in the very last slide. I cite the tutorial, okay? So if you want this weekend, you're welcome to go through the tutorial, but I'm going to go through half today and half Tuesday. Right? Today we're going to go back end stuff, and Tuesday we're going to hook it up front end stuff. Right? So we're going to essentially do server today and client on Tuesday. Now server, I want you to understand, that is a Node application. It's not a React application. It has nothing to do with React whatsoever. Okay, the front end could be Angular for all it cares. The front end could be anything. The front end could be Java. The front end could be whatever you want the front end to be. And by saying Java, what I really mean is that it could be generated. It would still be, in the end, for the browser, HTML, JavaScript, but it could be generated by like something like JSPs or servlets or whatever. Okay? So, understand that server is a backend API. It is a Node application. Right? And I encourage you right now to click in here and actually look at it, right? If it's a Node application, when we click in server, how do we know immediately it's a Node application? When you look and click inside that directory, you will immediately see that it's a Node application. How? Yeah. Package.json. If package.json is in that directory, it is Node. Let's see. Click. Here we go. Package.json. There it is right there. Okay? If I open package.json, I get this. And you're like, what's that? I don't see a whatever, script or whatever. Right? You're just going to run the index file is what you're going to do. Okay? This index.js. You want to start the server, right? Which I did over here. Here I am. All I did is I say node. Oh, actually, installed nodemon first. I didn't have to. Nodemon is something that's in the homework 3 instructions. It's called a process manager. It just basically means start this thing, and if it crashes, restart it. That's all it is. Okay? But I could just say npm run index.js. Okay? So what I want you to do right now is, for this repo, clone it. But wait a second, clone it? This is the server. Okay, we have a bunch of stuff. We're going to go through this. But we have 2 directories here. We have client also. Yeah. Right? We have 2 of them. So, we only have 1 repo. But the repo has 2 node applications. Right? So you are cloning the top level. Right? You are cloning the top level, right? This is the top level right here, right? Just the top level app. And inside the top level app, all right, and you can look at the documentation in the README file, there is a client directory, which has the React stuff. That's 1 application. And then you have a server directory. And that is the backend API, which we're going to get into. That's also a Node application. It has nothing to do with React. Doesn't even know what React is and doesn't care. All right? And I want to make that clear just because I want you to differentiate between backend API and React. Those are 2 completely separate things. You can attach a backend API to any front end at once could attach to a backend API. Like the one that we're doing. Okay? All right. So let's get into this. Okay? Now we have a couple of things. Here we go. Let's go all the way to the top. Did I say 416? This is not 416. That's the wrong course number. All right. So let's go to the top here. First things first, download and install. Go to our lecture slides there if you want the link, or you can just go to Google and say MongoDB Community Server. I have to check it periodically because the link changes periodically. So I just checked it yesterday, and I installed it, and everything worked perfectly. I also double-checked Postman, and after they tried to extract money out of me in 100 different ways, I was able to then download it, install it, and use it for free. And both of these you can use for free, for our purposes. Right? We can use them both. Right? So there's no reason to pay 1 cent for anything this semester. Just be aware of it. Right? But you can download both of these. You can install both of these. What are they for? Well, I've already told you what the MongoDB Community Server is. It has the database, 1. Right? So it has a server which runs, which will receive requests to create, retrieve, update, and delete things in the database. And again, our server that we will define will use the Mongoose library to talk to it. And Mongoose knows how to talk to it, we just have to know how to talk to Mongoose. Next one there is Postman. I like Postman. It's a simple little program that knows how to send HTTP requests to servers, to backend servers. Now, you have to know what format to send and what the address of the server is and things like that. But we can use that to test our backend API. And that's what we're going to use. We're going to use it in homework 3, 4, all the way to the end of the semester. You're going to use it, presumably, for the rest of eternity for testing backend APIs. Although someday they'll start charging you too much money or something, but for now it's free. So, we'll use that essentially just to make sure our backend API, in homework 3, it's important we use both of these. To make sure the backend API is doing all the things that it's supposed to. Right? So, again, if we think about this, our backend API is actually going to act very much like what's called a RESTful Services API. Right? It's not even going to remember anything. Okay? Meaning, a request comes in, we have code there waiting, we'll call it controller code. Right? In fact, let me go back one step. A request will come in, we will route it, we will figure out, what kind of request is this? Where should we route it? And we'll route it to the proper controller code. And the controller code will say, oh, okay, what do you want? What data did you send with the request? Oh, you want a playlist for all the songs by this artist in this year? Okay, let me go to the database, and I'll send a request there, and get it back, and then I'll send it back. And then it's like, I'm done. Doesn't remember anything. There's no socket, if you know what a socket is. A socket is a continuous connection. If you ever play online games, you have a socket. A socket is a continuous connection. We don't have that. Some web applications might have sockets. Sometimes there are sockets. Again, if you want collaborative editing or collaborative anything, you might have sockets. Maybe. In 4.16, we do projects with sockets. That requires multi-threading. It's much more complicated. Right? But here, one and done. A request comes in. Like, if you think of the backend server, the backend server has no idea who is sending the requests. It doesn't care. It has no idea for what purposes you're sending it. All right? I think I mentioned this last time, maybe. One semester in 4.16, I had my students make a fantasy football website. All right? If you've ever done any fantasy sports, right? Fantasy baseball was the first one. For years back in the 70s, but I think the most successful, popular one these days is probably fantasy football, you know, with all the gambling stuff and everything like that as well. We used an API, a backend API provided by NFL Data. They let us use it for free. And they gave us each a license, and in every request we sent, we just had to include our license. So when we send a request to that backend API, again, the backend API there at NFL Data, it's just getting a request. It's like it's getting a letter. And in the letter, it's like, who's this from? Do they have permission? Oh, yeah, they provided a license. What do they want? Oh, they want this. Okay, database, blah, blah, blah. Send it off. Okay, we're done. The next request. Oh, okay, who's this from? Somebody different. You know, they want something else. We got to verify it. Blah, blah, blah. We'll get into web security and stuff like that and how we verify things. But that's basically what a backend server is. It doesn't have to set up a connection, like a continuous connection, things like that. It might store things like session data. We might have some session data maybe that it puts into a database, which it keeps for some amount of time, right? To keep track of when it should log you out or something like that. It might do that, right? But for the most part, it's one and done, all right? So, we're going to see that our backend API, right, it's going to require a server, all right? We're going to use Express for that. And Express, in total, the Express API, I think, will use 5 methods. And we're going to see all of them today. I don't even know if we're going to use any more than that. Understand that Express is doing these powerful things and we barely even touch it. All right, so we'll see that. So Express is the actual backend server that we're going to put in that index.js. Of course, we're going to have a couple of different types of databases. One in homework 3, different one in homework 4. Because of that, we're going to use different ODMs. We're going to test these things in various ways. In homework 3, we're only going to use Postman. But later we'll talk a bit about Jest and vtest. And maybe one might use a query language, although we're not using it, right? Maybe later in the semester I'll talk about GraphQL. I haven't decided, because it's a Facebook thing, and it's an interesting idea. When we talk about routes, I think we're going to talk about it. But anyway, so again, the whole idea is, hey, we have this server running. We can give it things to put in the database. Just, hey, put this in the database, we're done. Okay, get this from the database. Okay, thank you very much, we're done, right? It's just like this correspondence back and forth with HTTP requests. Now, I want you to understand, we have not yet learned how to send a request. All right, we're going to do this on Tuesday because we haven't yet seen in the front end, like our React thing. You know when we use DB in our React program in homework 2, we are talking to local storage, but we're going to change it so that we're talking to the backend API. We'll do that. All right, we'll do that in class on Tuesday, and that's going to be for homework 3. So understand that backend API is sitting there waiting for requests to come in, and the requests might have data. I mean, again, think about a request that has data. What are you asking for? Right? If I'm asking for a playlist with a particular ID or a playlist that contains a particular song or something like that, later in the semester, at the very end of the semester, you might want to know what's the most popular playlist, meaning the one that got the most likes, or which song is most popular. Because I'm going to get playlists from every single student in this class, and we're going to combine them all together, and we're going to use that aggregate data because we're going to put them in all of our databases, and then we're going to play around with it and use that as test data, okay, for our application. So, for this to work, like for our backend API to do all these things, we need to be able to distinguish between different requests. Right? So we have to distinguish between different requests because the server needs to distinguish between different requests. And one way that we do that is with the term called an endpoint. Okay? So an endpoint, which we would typically think of as a device, right? We have all these different endpoints. So broadly speaking, these are endpoints. But we can also think of, within a server, that server having multiple endpoints. So a backend server may have many different endpoints. Let's see if we can figure out what would be good for homework 3. What do you think would be good endpoints for homework 3? How about create playlist? That sounds like a good endpoint. What would be another one? Like a request that comes in and tells the server, create a playlist. Yeah? Edit the playlist, absolutely. That's another good one. Like there's one that already exists, but I want to change something. Here's the new data. What else do you think would be good?
Delete playlist.
Delete playlist. Right? These are the obvious ones. Remove playlist, right? Something like that. Get playlist. CRUD. Right? Now, those 4, create a playlist, read a playlist, or get, update a playlist, or edit, remove a playlist, or delete, CRUD. Those are the 4 basic things that your backend server would do. And you might say to yourself, okay, every database just does that. Just create, retrieve, update, delete, right? Do we even need a backend server? I mean, what is a backend server? What else does a backend server do? I mean, isn't there some way we can just communicate directly with the database rather than get this backend server involved? And the answer is, well, if you're only doing create, retrieve, update, delete, then actually you don't need the backend server. What you need is you need something like Firebase, right, which we're not using. Anybody know what Firebase is? Yeah.
Yeah. It's like a backend, but it's only you don't do anything.
Yeah, you don't get to add any additional logic for any other stuff. Okay? Although I guess they've maybe made it so that you can do some things. I'm sure that they might host these days. But traditionally you would just, hey, here's a CRUD database, you control it there in Firebase, which is now owned by Google, and you can just make those calls directly to Firebase from your front end, and you don't even have to maintain your own backend server, right? Or you have a backend server and it just basically uses that database, right? That's another way of doing it. I have a game that uses that, right? But if you want any custom stuff, I mean, if you want to manage rules and talk to other third-party software or like a whole other bunch of complicated things, right, then you need to maintain your own backend server, and your backend server has to do all of those different things, okay? I have a a game where we have a front end, we have a back end server, and then it talks to Firebase, and the back end server enforces all of our game rules. So it makes sure nobody's cheating, and the timing of everything, and a whole bunch of other complicated things, right? But you could make a simple application front end that directly CRUDs to Firebase without having to have your own backend server, but then it's limited in what it can do. All right, but it might be good for certain applications. Okay, anyway, so what we want to think in terms of, all right, what are our endpoints? Yeah, we don't have terribly complicated ones for homework 3. I mean, we only have a few things that we're going to be doing, and we're going to differentiate between those things by having different what we call routes. And a route looks like a path, okay? So in the URL that you're providing, it might look like a path sometimes, okay? But for our backend server, we're going to say, hey, we're going to listen for routes according to what the method is. Okay, so we're going to see that we're going to have a method of the request, what the path of the request is, and then we're going to specify the code that's going to be the handler. And that's really going to be what we call a controller, right? So this is going to be code, we're going to see an example in just a second. That's going to be very repetitive, right? And actually backend server code is very repetitive, which is good, right? It means that, you set up the infrastructure for all of this stuff only once. You set up the architecture only once, and then you're spending the rest of the time doing the interesting things. And the interesting things mean, what data can I extract? And how do I extract it? Things like that. I'm a big baseball fan, right? If you've ever watched a baseball telecast, you'll know like the statistics that they will present are ridiculous. Okay? This player has hit more home runs on a Sunday after eating an ice cream cone than anyone in history. I don't know where they get that data from, but so that's kind of the interesting thing. Like examining that stuff is much more interesting, right? Which is about, of course, writing interesting analysis algorithms and things like that, right? So you can think in terms of something like the playlister, right? You can imagine Spotify. Spotify does all kinds of things with the data that they collect. I mean, they have enormous amounts of data. What's the most important thing that they do? Well, cheat artists out of money, right? That's the most important thing Spotify does, right? It's really important that they keep all of it, right? So, we're reading about Spotify losing money, I mean, everybody I know has it. Not me, right? I'm such a cheapskate when it comes to streaming platforms. I'm an academic. The academic should have to pay for anything. Anyway, so what we're going to see is that we're going to use this idea of routing to differentiate between different requests. And we'll see that in just a minute. The whole point, though, is that on our server, imagine this is a server, we have these requests come in from the internet, i.e. from a client, i.e. a React application. And it goes to what we'll think of as our routes or our routing manager, whatever, and it will figure out which controller to send it to. The controller will then presumably read and write data to and from the database. Maybe, depending on the technology that's being used, it might be feeding a template which it sends back. We can do this with Next.js, right? We can do server-side rendering in Next.js, okay? But we're not going to do that in homework 3. But we could. But instead, what we're going to do is we're just going to send back a response, and that response, if it was rendered there, would be HTML. Otherwise, it would just be JSON data. Send it back, and then that React application can use it in something, right? So I want you to understand that the server gets a request, sends back a response. For us, this semester, and this is pretty common, most common probably, the format is going to be JSON. All right, so everything we send to the server is in a JSON format. Everything we send back. Now, what's the format of the JSON? And the answer is it's up to you, whoever the developer is, as long as the client and the server know it's the same format. So when we used NFL Data's API, because we had as a requirement for that project in 4.16, it was like, all right, Sunday games are on, I want to see your application update live. We have to know the format that NFL Data is going to be giving us the data, right? And we have to know what are the fields that are going to be in there, right? So that we can pull the data out and use it. Otherwise, we have no idea what's in there. And if we're going to ask for something, NFL Data has an API that says if you want to ask for something, it has to be sent, the request has to be sent in this format. You need to send us a JSON object specifying which game, and the game has, an ID and other details. If you want to know about a certain player, ID of the player and things like that. So you have to send the proper data in the proper format, and then you get back data in a particular format. Now that's what we call the interface of the backend server, all right? The interface. The interface basically means the agreement between the backend and the front end. They have an agreement. And really what it is the backend server is just saying, hey, anybody wants to use this backend server, this is the format of the requests that you send, the format of the JSON files, and this is the format of what we send back. Okay? Now again, I'm simplifying some things because we can only do so many things in this class. I do realize it can be much more complicated than this, and there are other formats and all kinds of stuff. But this is the basic gist of everything that we're doing here with HTTP server. All right? So they both have to know what's in that payload. They both have to know what the types are, what the format is, all of that different stuff. All right? So we're going to do a little example, which is again the one that I've asked you to reference there, the one to load and look at, which is a backend server with databases. And I actually have it running here. And actually I don't even know if I have anything, I probably don't even have anything in it right now. But I opened up Compass and I opened up Postman and I sent a request to create something and it created it in the database. In fact, let me see, what did I create in that database? Down here, here's Postman and I sent this request. All right, I have a request right here, create Goodfellas was the name of the request. I added a movie and I said name was Goodfellas, time, and the rating, it's a 10 out of 10. Time, I actually don't even know if that's the right time, but I just sent that and it sent it and it ended up in the database. So I come over here to Compass and there it is, it's in the database. Okay? So, that's the example that I'm going to be referencing here, all right, in the subsequent slides. Okay, so let's kind of break it down. All right, let's break down what's in that example. And again, I really encourage you, have it open so that you can jump around there. You can have it open either you can certainly run it, right? Again, all I did to run it, I think I showed you, is I just did that npm run index.js, but you have to be in the server directory. Because that's where the index.js file is. Alternatively, in the homework 3 instructions, I'm going to tell you to install that process manager nodemon, and you can say nodemon index.js. It just does the same thing. And again, nodemon is just, if it crashes for whatever reason, it just restarts. That's all. Anyway, so I want you to understand, Express is a node server. It's a very basic server, but it has a few methods. It does important things, but it has a few methods that we're going to make a lot of use of. We're not going to use a lot of methods, just a few methods, but we're going to make a lot of use of them. Okay? And one interesting method that it has is use. U-S-E. Express use. That function is one of the more important ones. Okay? Because what is it using? Well, it's using something called middleware. And that's actually what that is. Like people, you're going to look at the slide and say, oh, we kind of forgot to edit the rest of the slide. No, I am actually explicitly saying Express is the backend server and use is this function where we specify what our server is to use. Now, what does that mean, middleware? What does that mean, our backend server? I want you to understand it's like this, all right? It's like this. The backend server is here, all right? So here we have Express. It receives a message. And the question is, what do we want to use? We could actually have it use all sorts of things. Like chain them all together and use pre-made libraries, really, or our own custom code. And really what that means is let's send the message through those things for various reasons. All right, so we will process the message through that middleware, the things that we associate with use, for various reasons. So if you look, anybody, server index.js, what do you see? What is it using? Yeah.
A function called cores.
A function called cores, the cross-origin API, okay? We're not going to care about that just yet. We'll care about that when we cover web security. That is a web security thing, all right? Another one, what else do you see in there? Express.use. What else do you see? Look at it, are you? Don't make me get it. Yes?
I also mentioned, but is the cross-origin request service?
That's what Brian just said. Yeah, that's the one that we just said, cores, right? And again, we will learn all about that when we get into web security, which we're going to be using homework for accounts and stuff like that. Yeah, so that, I think that might even be the first one there, maybe your second one. What else is in there? There's got one in there, I think, right? In that code? I think there is. Not terribly embarrassed. Is there another one? Is everybody looking at the same thing? Server in that repo and in index.js? Huh? So listen is the express, that's the last thing you would do. Listen is like, let's listen on this port. Anybody communicates. But in the setup, before that, is there any other call to the use function? Any other calls to the use function? What other middleware is it using? Yeah. Yeah, that body parser thing, that JSON, right? It's basically saying, hey, the requests are going to come in and the data is going to be in the format of JSON. Okay? Remember we said we're going to send requests and the data we're going to send is in the format of JSON and the things we're going to send back is in the format of JSON, right? It doesn't have to be. And one tricky thing, just so you know, which will drive you crazy if you don't understand this, is that, again, you can send requests in different formats. If I go over here in Postman, here's Postman, when I'm specifying, right, the format of a request, because here I am, create Goodfellas up there, right? If I go over here, I can specify what the actual format is. Let's see where I do that again. Settings. So I can actually specify what the format is. Somewhere in here I can specify whether it's using, I'm going to say somewhere because I don't remember. Oh, they even have a GraphQL now. Oh, interesting. Okay. Oh, right here. There it is. JSON. I'm specifying, hey, the format of my request is going to be in JSON. The data is going to be in JSON. Right? But it could be in something else. Like if I were to do this, if I were to send it like this, like I'm just going to send it as XML. It's another format, standard format. The server is going to be like, what's this? This is not JSON. It doesn't obey JSON. It's going to spit it out and it's going to crash. It won't wake up. Okay? So understand that you have to, since we're using JSON, this Postman is pretending to be a client. It's going to generate a request and send it. Just the way that our React program will. All right, we're going to learn how to do that too. Our React program can send a request to the backend server, knowing its port number, which will be different from the server that will be serving the React application. There'll be different port numbers. Right? So, all right, we're going to send a request to the server is going to get it. Since our client knows it's going to be in JSON, not XML, we better make sure that our server knows that it's in JSON, not XML. Okay? So that's another one of the middleware there. So it's making sure that everything gets processed as though it's in JSON. And if it was an XML, it'll be like, what is this? This is not JSON. Okay? All right, so we have a few things that we need to do. Again, look inside server. Look at the top all the way down. You see all that code? We're rarely going to change that code. Like, we're stuck with that. Much of it is what we call boilerplate code. Some of it you will. I mean, we'll add something for loading environmental or variables, things. That's one thing that we'll add for hidden variables and things like that. So we'll add it for a few other things. But we're not really going to change that file that much. The other stuff is going to change. The controllers are going to change, for example. All right? But what are the things that we need to do? Okay, so first of all, we need to set up our server. Again, create the server. That means make the express object. Specify all the middleware. That means all of the use functions. All of those use is at the top. And then the one right there we haven't really talked about yet is specify the routes. I've mentioned how routes are going to be the way that we differentiate. Hey, a request comes in, who handles it? Okay, that's what the routes are going to be good for. All right, so we're going to specify which controller code handles which requests. We're then going to set up our database connection. Okay, remember we said that the database has its own server. When you install Mongo, it's Mongo Community Server. It's its own server. So you have to set up the database connection, right? So that your server can talk to the database. Next, specify controller functions. They're going to handle all the routes, right? We then set up the database, right? Meaning we are going to load it with data and the format of all the data that we want to put in there, right? We may then write all kinds of functions for asking the database complicated things, like with queries, and writing things to the database in all kinds of complicated ways. And homework 3, our requests are not really going to be very complicated. In the final project, they'll be more complicated. All right? But homework 3, the requests are just CRUD. Just like that. Pretty straightforward. All right, we'll gradually work our way there. All right. So these are the things that we have to do if we want to make a back-end server, which is much of what you're doing in homework 3. Right? So here we go. Here's the code. Express, we make it up top. We make our cores object. This is common JS. So, I mean, this is node. Node is that require. If you ever see require, you know you're a node. That's not a JavaScript function. That's a node thing. All right? I am right there. App equals express. That's where I am making my express server. That's called app. I am loading it with 1, 2, 3, and 4 middleware. Right here. Remember this little box? Request comes in. We have 4 things to process that request. One right after the other. The order with which you do that is the order with which they appear. So the first block right here is the URL encoded thing. All right, that's the first thing. The second thing is the cores thing, which again we'll learn when we get into web security. The third thing is the important one, express.json. We want to make sure that that is JSON because the requests we're going to send are going to have JSON data, as I just showed you in Postman. Right? And the fourth one is our stuff. Like those 3 are all APIs, and we're not going to change that. We're just going to leave that exactly the same pretty much the whole semester. But that, the fourth one, that's different. Okay? Because that one is our backend API. So we're using /API, and we're saying, hey, we're going to have routes, multiple routes. In fact, in this example, we have 5. And we're going to have something called a movie router. You can see that we make one here. All right, we make a movie router. That's actually a file. That's a source file. If you look inside the repository, if you look in the code base and you look inside the routes directory, you'll find the movie router file. And you'll see that it has 5 routes. Look at it right now. You'll find 5 routes in there. Can anybody tell me a request that is being handled by movie routes? Somebody tell me a request that is being handled by movie routes. By this thing right here. Or movie router, I'm sorry. Anybody find one? Yeah. Create movie, absolutely. There's one. What's another one?
Update a movie.
Update movie. I'll take your word for it. I think that's what it's named. Yeah, those are all in there. I mean, again, look, I want you to understand, this is our middleware, this one. This is our middleware. We are defining this. This quote, routes, movie router, well, I say we, it's really whoever made this API. Right. Let's see, where did I go here? is my API. Is it over here? There it is. So, if we go in here into server, again, the idea is, again, index is the thing that we run, right? This has all of this. Oh, it's a little bit different. I actually changed a few things. In my example, I think I simplified it a little bit. All right, we still have express. We have this router, so on and so forth. I guess I need to do some of the other stuff. Oh, I changed it, that's right. I changed it. So you can see we're still using the body parser, we're still using cores. The way with which this works has changed. So this was an older version, so I had to update it because of newer API. But anyway, if you go to routes and you go to movie router, here it is. These are all the routes. 1, 2, 3, 4, 5. So this is what we call a router. Doesn't look very interesting. What do you think it's doing? Yeah?
It's passing back and forth. So I think post is where, so get is where it gets information from like the front end. And then, I think the other one is it can get information, return something back to the front end. It is like passing data back and forth from the front end.
So this is a very good guess. And this is a little bit tricky because I called that the method in a previous slide. Okay? So let's first talk generally about this file. Generally about this file, we think of this router file that's just like a traffic signal. That's all it is. That's all it is. It's just saying, hey, when a particular type of request comes in, what happens? And movie control dot get movies, this really means controller. Again, that's one of our files, and that's one of our methods. Okay? In fact, you can see that we are getting it up top. Right? Like we're getting movie controller there because it's actually defined inside of this thing. I'm going to jump back to this in a second, but if we were to go in there, if we were to go to controllers, movie controller, you can see, oh, here's create movie. Okay? So create movie, you can see this is a function, it does a bunch of things. Update movie, you can see it does a bunch of things. Oh, look at that, find one. Remember I mentioned find one? Movie.findOne. Ooh, okay. Remember I said that before? Well, there's other things that we're going to do with the database, right? I mean, let's see. Get movie by ID, find one. Get movies, find. Oh, I thought it was find all. It's just plain find. There's no all in that. What other things do we see? Oh, find one and delete. These are things that Mongoose knows how to do. These are Mongoose functions. Okay? How about creating something, Mongoose? How do you create something? Let's see. Mongoose creates something by saying oh, new movie, and giving it what? Giving it the movie data which came from the request.file. Okay, so the request comes in JSON, we get the body of that request. Why is it the body? Remember over here, back over here in Postman when we were sending our requests and we said, hey, what's the body of our request? That's the body, right there. That's the body. The body has the data that we're sending as part of the request. So we get this thing, request.body, and we get that, and from that we make a movie, and then we do interesting things with that. Right? So, what do we do with it? We call a function called save. And that is a Mongoose function. Save is a Mongoose function. It saves that thing, that movie, to the database. Right? I mean, that is a nice, easy function to create a new object in a database. Save. So save, find one, we already saw find, we saw find and delete, we just have pro. 1, 2, 3, 4. All 4 things. Save, that creates a new one. Find by ID or find all, or no, not find all. Find by ID, we had, how about update? What would update be? I think it's just finding it, changing it, and saving it, I believe. Let's see, update. Find one, right? After we find it, we change it, and then we save it. There we go. Update is nothing special. Right? So we find, we change it, we save it. There we go. Save saves your object. Now, I said I'm going to go back to the router, right? Because again, this router here, this thing right here, the movie router, again, I called it the traffic signal, right? It's essentially directing traffic in different directions. And these are our functions. Like, it's like, hey, when this type of request comes in, call that function. Now, and it's going to send it the request file. It's going to send it the request, and from the request, you get the request file, i.e. the data, right? But in your answer to the question before, you noticed that, these things, get, delete, put, post, what are those things? And if you look here, as part of these things, what are these things? Well, you'll notice there are 5 different types of requests, meaning we have 5 endpoints. All right? So if I were to give you an exam question that looked like this, and I said, how many endpoints does this thing have? Your answer would be 5. How many endpoints does this backend server has? It has 5. Right? Router has 5 endpoints. Okay? How many paths or routes do we have? Well, we have movie for the first one, and for the second one, and for the third one, and for the fourth one. The last one is movies. There's only 2 routes, right? Really, or I guess you should say paths. Okay? What does that mean? Well, it means that it needs other ways to differentiate between the requests. The path is not enough, right? So we need another way to differentiate, and that's what these methods are. And I want you to understand, these methods right here, these are HTTP request types. That's standard HTTP request types, okay? In fact, in Postman, and I was showing you that before, you can specify what the type is, okay? So you can specify as part of a request, like what kind of a request is it? No, actually, I take it back. Where am I putting that? Where is that? I'm looking for where it's specifying get. If I come over here, let's create the list. Where I specify get. This is the request. You can see it's being sent in, it's being routed to the API, which is our movie router. And then the path is movie, but in here somewhere I'm specifying that it's a get request. And I don't remember form data, no.
Can you change that post button?
No. Which one?
The post button on the top left.
Oh yeah, there it is, duh. So if I open this up, all right? If I open this up, so I'm sending this as a post request. Okay, I'm sending this as a post request. If I open this up, this drop down, what else do you think I'll see there? Yeah, the other ones that were in there. Remember on this slide? The other ones that were in there. Post is one. So I'll also see in there put, delete, get. Now, I want you to understand, those things are not really magical. There is a difference between post and get. There is a difference, which is that the data that you send as part of a get will actually be in the URL. Whereas if you send it as a post, it's not. But all 4 of these can be used to do pretty much anything, actually. They're not really magical. The backend server can choose to do with them whatever they want. It's just there is that differentiation. All right? I mean, I can get a delete request and not delete stuff. I can get a delete request and create stuff. Right? It would be a terrible thing to do to the developers using the backend API, but I could do that. Question?
Can you have a router have the same HTTP request, like say .get, and same path, but a different movie control function?
So there has to be a unique differentiation between each request. Now you can have middleware, as we're going to see in homework 4, we're going to have other middleware that's going to route every single request through a security manager to make sure, oh, you requested this, let's make sure that you actually have permission to do this. So we're going to have another use for that. So, oh, you're going to create, do you have permission to create? Maybe you only have permission to view, right? So we're going to add an additional thing for that so we can have, in other words, we can have multiple routes, or so to speak, multiple controllers essentially execute on a single request. And we'll do that in homework 4. Now, understand again, post, put, delete, get, those are 4 methods associated with HTTP. Okay? And understand, if we go over here, we go, open it up, there we go. Get, post, put, delete. Forget about the other ones. Right, there are other ones, but forget about. Okay. All right, everybody.